So yesterday we talked about circulation. Okay. So today we will talk about velocities of blood flow. So how the blood flow, we have to know about that. Which speed the blood will flow, we will know in this class. The velocity or speed with which blood flows differs in the various parts of the vascular system. Velocity is inversely related, meaning as one value goes up, the other goes down to the cross section area of the particular segment of vascular system. The aorta receives all the blood from left ventricle. Its cross sectional area is small, but about 3 centimeters, and the blood moves rapidly, at least 30 seconds per minute. 30 seconds per second, sorry. Each time the aorta or any artery branches, the total cross section area becomes larger and the speed of blood flow decreases. Think of a river that begins in a narrow bed is flowing rapidly. If the river bed widens, the water spreads out to fill it and flows more slowly. If the river were too narrow again, the water would flow faster. This is just what happens in the vascular system. So basically, the velocity is depend upon the area. Means the speed is depend upon the area. So meanwhile here, if the artery is big, the velocity, the speed of blood is slow, because this is narrow. Yeah, more blood will rush, so it will go slowly. No rush is there. So if the blood is the vessel or artery or vein is narrow or nor it is wide, this is narrow or constrict a small area, so then the speed of blood is increases, so they have to go forward. So depending upon the area, the speed increases, the blood speed increases, the blood speed decreases. But actually, we want to know about the left ventricle. From the left ventricle, it will enter into the aorta, aorta to all parts of the body. So this is very important. We have to understood that speed here from the left ventricle. So from the left ventricle to the aorta, there is the centimeter here given is 3 centimeters. 3 centimeters, 1 square inch. Okay, so the blood will pass here very rapidly. Okay, very rapidly. Okay, so this is thing we have to remember, because from the aorta only we are receiving blood. The capillaries in aorta total the greatest cross sectional area, and the blood velocity is slow, less than 0.1 centimeter per second. So 0.1 centimeter is the area covered, okay, by the blood in second. Here in 3 centimeter, 30 centimeter per second. So here the area is reduced. Okay. When capillaries unite to form venules and then veins, the cross-sectional area decreases and blood flow speed ups. Again here, the cross-sectional area is decrease. So again, the blood flow increases. Okay. Recall that it is capillary network that exchange of nutrition, waste, gases take place between the blood and tissue fluid. The slow rate of blood flow in capillaries permits sufficient time for these essential exchanges. Think of a train slowing down at station to allow people to jump on and off, then speeding up again to get to the next station. The capillaries are the station of the vascular system. Okay, so basically here in the capillaries, the blood flow decreases because we have to send all the needed material to the cell, and we have to take off the all the required unwanted material from the blood. So there's the reason blood is flowing in the capillaries is decreases. We also know that 35 to 30 to 35 millimeter per Hg per mercury is the normal blood pressure in the capillaries, in the blood vessels at the ending in the capillaries. So basically, so here the speed decreases in the 1 second 0.1 centimeter. In the beginning 30 centimeter for 1 second. Okay. The more rapid blood velocity in the other blood vessels makes circulation time quicker short. This is the time it takes for blood to go from the right ventricle to the lungs, back to the heart to be pumped by the five left ventricle to the body, and return to the heart again. Circulation time is about 1 minute or less and ensures an adequate exchange of gases. So basically, uh, the reaching of all material to the cell is the main goal of the heart. Okay. So heart pumps, then only the material required material of the cell will reach. If the heart doesn't uh, flow or doesn't circulate or doesn't do proper action, the blood cannot reach to the cell and cell will not get all the proper nutrition. So that's the reason we need blood pressure. What do you need? We need blood pressure for the maintenance of blood velocity or blood speed. So now, so here we will discuss in detail about blood pressure because blood pressure is very important topic. In that we have all the things related. Okay, and second is regulation of blood pressure. How the blood regulates means always our body is maintaining 100 by 60, 110 by 80, 120 by 80. So these are the two things we have to remember. One is blood pressure, and second is how the blood pressure is regulating. So let's talk about blood pressure. Blood pressure is the force the blood exerts against the wall of the blood vessels. Filtration in capillaries depend upon blood pressure. Filtration, filtration bring nutrition to the tissue. Blood pressure is one of the vital signs often measured and indeed a normal blood pressure is essential to life. So basically, why do we need blood pressure? We already explained. We already know about that. In first thing, basic thing, we need blood pressure to collect the important material which cell needs, because in the blood only all the materials which are required to the cell is there. Okay, cell required oxygen, it is present in the blood. Cell required glucose, it is present in the blood. Proteins, amino acids, whatever important things are present in the blood which required by the cell is present in the blood. So with the pressure, the blood cells reach to the cell, then only all the body cells will get the necessary things. First. Second thing is after the functioning of the cell, we have waste material also. Likewise, whenever uh, we eat food, whatever the substance is remain, that is waste product. So we have to throw out. If we keep on keeping on the in our home, what will become, it will give a bad smell. Okay, and it will cause bacteria, fungal there. So likewise in our body also same things. If we cannot excrete urea, creatinine, okay, all those waste substance have to be eliminated from the body. So with the help of blood pressure only this happens. So two things will happen with the help of blood pressure only. If the blood cannot be in the normal range, what will happen? That we will receive small amount of oxygen, small amount of glucose. So what we will feel? We feel weakness, tiredness, giddiness, dizziness, anything, because our brain need large amount of glucose continuously. So if blood pressure is decreased, it is less than 100 or 90, what will happen? The amount of blood cannot reach to the brain, so brain will decrease the function and we will feel weakness, dizziness, giddiness. Okay, so this is the basic thing. Second thing is that if the blood pressure increases, what will happen? The happen is the capillaries cannot bear that amount of pressure. It may be burst. The arteries also cannot be. If I am hitting the ball, I am crushing this bottle with some pressure, 20, 30. So it is okay if you give that pressure. If I am giving 50% pressure, it will uh, connect, it will contact. If I am giving 100 pressure, what will happen? The water in the bottle will comes out. Likewise, here also we have phone. So it fell down from smaller height, doesn't happen. Is it are forming from more height? What will happen? The things in the phone will not bear that much pressure and it will break. Okay, so all this in natural thing that everything have pressure barrier. Okay, likewise our body have pressure barriers. The arteries will bear some amount of pressure. Our capillaries bear some amount of pressure, and our kidneys, everything. Okay, so there are the chances of organ damage if blood pressure increases. What will happen? Forcefully blood is coming to the body. Meanwhile, we have two things in the body very important. That is lungs. Lungs receive large amount of blood. Kidney receive large amount of blood. So it to filter it. So continuously it working. Continuously it working. So what will happen? It can have more pressure. The cells in the kidney nephron will damage. Or in the brain, we have small arteries. Yesterday we studied about the circle office. So what will happen? This arteries will damage. Okay, these arteries will damage. So brain, if the BP increases, it will also damage to brain. If BP decreases, what will happen? It also damage brain. Okay, so these are the things, important things. That's the reason we have need to understand about blood pressure. We have to study about that. The pumping of ventricles created blood pressure, which is measured in mmHg, millimeters of mercury. So what is the full form of mmHg? Millimeters of mercury. When a systemic blood pressure reading is taken, two numbers are obtained, systolic and diastolic. So whenever we are measuring blood pressure, so what we have two things, that is systolic and diastolic. So how the blood pressure indicates, what indicates blood pressure? Blood pressure indicates that our ventricles pumping, our ventricles are working. It will contract and it will relax. It will contract and it will relax. So next we have systolic and diastolic. What is systolic and what is diastolic? Systolic pressure is always the higher of the two and represents the blood pressure when the left ventricle is contracting. So basically systolic, please remember, systolic means contraction. Diastolic means relaxation. If the systolic is connected to the ventricles, we will call systolic ventricle. If the diastolic connected to the ventricle, diastolic ventricle. We can also say systolic atrium. Diastolic atrium means atrium contraction, atrium relaxation. So we need more pressure to give the blood to the organs because you have to enter all body parts. So that's the reason the blood pressure of systolic is higher than diastolic. It is 120, we all know. Okay, and diastolic because they have to collect the blood, so it needs not much amount of pressure. So that's the reason diastolic is less. So understood, because this wording, this terminology is very important. So whenever patient comes to your clinic, please check his BP. It will give impact on the patient also. Okay, mental impact. If you are not able to see the BP, please uh, give the put your one person to check the vitals or anything. He will check all those things. Okay. So basically, BP gives the information about how the ventricles are contracting. If the contraction is more, BP upper end is more. 110 is become 120, 130, 140, 150, 160. So contraction will release the blood from the ventricles to the organs. Relaxation, if the relaxation is more, mostly diastolic is not more. Systolic is more. Diastolic is normal 100, 90, that much. Diastolic is more 140, 150, 150 by 90, 170 by 90. I saw the patient of more than 240 blood pressure. Okay, so 240 by 80, 100. Okay, systematic blood pressure is highest in the aorta. So beginning from the ventricle, aorta have more pressure. So likewise, when the blood is reaching to the last organ, last cell, the blood pressure is decreased. Example, I will give that you throw a ball. First, it will go forcefully. Then the force of second wave is more lesser than first wave. So likewise, lastly, the ball hit and it will relax. So same wise, our blood pressure also. Systemic blood pressure is also high in the aorta. When receive all of blood pumped by the left ventricle, a blood travels further away from the heart. Okay, from aorta to other parts of the body. It will decrease blood pressure decrease. I told you the brachial artery is the most often used to take blood pressure reading. Here, a normal systolic reading 90 to 120, and normal diastolic is 60 to 80. In the arterioles, blood pressure decreases further. Systemic and diastolic pressure merge into one pressure at the arterial end of capillary network. Blood pressure is about 30 to 35 mm, decreasing to 12 to 15 mmHg at the venous end of capillaries. This is high enough to permit filtration, but low enough to prevent rupture of the capillaries. If blood flows through veins, the pressure decreases further in the caval veins. Blood pressure approaches zero as the blood enters into the right atrium. The upper limit of normal blood pressure range. So here, what will giving everything is giving. So the normal blood pressure is systolic is 120 to 90, diastolic is 60 to 80. So if the reach to the capillaries or arteries, that BP becomes 30 to 35, and in the capillaries it is 10 to 12, 12 to 15. So neither it will damage the capillaries, and we will our work also become easy. Okay, so it in the when the blood reaches to the right atrium, so what will happen? The blood pressure becomes zero. No, now the blood is resting stage, so the blood pressure is zero. Means the atrial blood pressure, not body's blood pressure. Okay, so if the blood pressure becomes zero, means the body is in died stage. Okay, the upper limit of normal blood pressure range is now 120/80. The wells of 125 to 139, one consider high normal or normal called pre-hypertension. That is, with the potential to becomes even higher. A systemic blood pressure consistently higher than the normal is called hypertension. A lower than normal blood pressure is called hypotension. The regular of systemic blood pressure discussed in the later section. So here blood pressure normal is 120 to 139, means 140, 120 to 140. And this is systolic. Diastolic means 85, 60 to 85. So here 90 to 145 is normal, 140, 139 is normal, 60 to 85 is normal. So more than that, if continuously the blood pressure is 140 means pre-hypertension, not completely normal. Okay, we consider as pre-hypertension. Above 140 means hypertension. The patient is in going to the stage of hypertension. Okay. Pulmonary blood pressure is created by the right ventricle, which has a relatively thin walls and thus exert about one-sixth the force of the left ventricle. The result is the pulmonary arterial pressure is always low to 20 to 25, and its pulmonary capillary is still lower still. That is important to prevent filtration in the pulmonary capillaries, which in turn prevent tissue fluid from accumulating in the alveoli of the lungs. So basically, you are right ventricle, right atrium, right? So right atrium, right ventricle, right atrium have the deoxygenated blood from all over the body coming from the superior vena cava, inferior vena cava, and enter into the right ventricle. So what right ventricle do? Right ventricle, right ventricle will send to the pulmonary artery to the lungs. So here the amount of blood pressure is normal than regular. Okay. Why? Because they have to be go to the pulmonary means and uh, lungs to then filter to the left atrium. So the oxygen have to be mixed with the blood. So that's the reason the blood pressure is here low, more 20 25 when it reaches to the lungs. So mixing of blood and oxygen will happen very smoothly. Maintenance of systematic blood pressure. So all over the body, how the blood is maintaining. So here we'll discuss that. Because blood pressure is so important, many physiological factors and process interact to keep blood pressure within normal levels. So we need most of the things, other supporters also to maintain blood pressure in normal. So we have venous return. We know that uh, from the uh, all over the body, the blood comes to from the superior vena cava, inferior vena cava, all over the body with these two large veins. So whenever blood receive to the heart, then only it will pump. Na? If you can't receive the blood, how can you uh, give the blood to the other parts of the body? Okay. If the venous return decreases, the cardiac muscle fibers will not be stretched. The force of ventricle systole will decrease. Starling's law, and blood pressure will decrease. This is what might happen following a severe hemorrhage. Here, one thing is explaining that venous return is very important. Venous return means the blood from all over the body will enter into the right atrium. Then only it will go to the right ventricle from the lungs to left ventricle, left artery, left atrium, and left ventricle. Okay, what will happen if the 100 ml blood have to be received in right ventricle? They receive 20 to 30 ml only. So contraction of heart will decrease. So there is chance of hemorrhage means uh blood is going. There is any obstruction, anything happening in the body. There's the reason blood is not reaching to the atrium. When the body is in horizontal, venous return can maintain fairly easy. But when the body is in vertical, gravity must be overcome to return blood from the body to the heart. Three mechanisms help promote venous return: constriction of veins, skeletal muscle pump, and respiratory pump. So when we are in sleeping position, it is very easy to return the blood. But when you are in standing position, what will happen? The blood, the gravitational force will bring the blood to the lower level. But heart have to be return the blood. Heart have to be receive the blood. Then only it will go the blood now. So what will body systems will have? We have three systems. This help to return the blood to the body. Okay. One is constriction of veins. Veins will constrict likewise, like constrict. And we have skeletal muscle pumps. Whatever skeletal muscles are there, like in the thigh region, in the leg region, in the arm region. So whenever we move, what will happen? The muscles will pump. The muscles will pump. And second is respiratory pump. We have respiratory system also, which is helping to get the blood to the return to the heart. Okay, veins contain, how this happen we'll discuss here. Veins contain smooth muscle which enables them to constrict and force blood toward the heart. The valve prevent backflow of the blood. So veins, how have they have smooth muscle, so they constrict. Okay, I told you in the second layer we have smooth muscle layer. Okay, and the second is skeletal muscle, which is specially effective for the deep veins of the leg. These veins are surrounded by skeletal muscles that contract and relax during normal activity, such as walking, contraction of the leg muscles, squeezing the veins to force blood toward the heart. So main is while we're walking, where is the deeper veins are there? If there is a leg, the deeper veins are present here. So what will happen whenever we walk, whenever do work, whenever we sit and lift our back, whenever we walk, we run, the muscles contract each other, and thus they contract. For their contraction, veins also contract. The veins contract. What will happen? Blood will flow from the veins to the body to the heart. Okay, it's from likewise two systems will help us. Next is third is respiratory pump, which affects the pain veins that pass through the chest cavity. The pressure changes in inhalation and exhalation alternately expand and compress the veins and blood is returned to the heart. Here, whenever we are inhaling, taking respiration, exhaling, releasing the air or carbon dioxide. So what will happen during the process? The muscles which are attached here, okay, or what will coastal region, or the lungs also a muscle, smooth muscles. The related veins which are connected to the muscles of the lungs will contract. They also contract. So more contraction will happen. Blood will go to the left side of right side of the heart easily. So likewise, we have three pumping section. We have to remember. So that's the reason blood. We need blood, but we have to give the blood. So, okay, two rules are important. If you give the blood, then only you will receive the blood. Okay, this is the law. So we have to give the blood first, then heart will pump the blood to the body. Okay, so that's the reason some people we the sedentary life which leads to only sitting, only eating, just sitting in front of laptop and working and going on the bike, car, everything. Now a sedentary life is there. What will happen? The muscles cannot be constrict, cannot be relax. So what will happen? There only one position. So that's the reason the muscles cannot be contract and venous return will not happen properly. So that's the reason patient cannot receive or person cannot receive proper amount of blood to the body. So whenever your patient come to your clinic, advise him to do exercises. Mostly I advise most of the patients stretching exercises. Stretching exercises will work deeply rather than doing jumping everything, but stretching exercise, you're stretching the muscle, so muscle will release all the tensions, whatever tension he had. Okay, the muscles will relax, contraction will happen, and circulation improves. So in that line we have yoga also. Some poses are very good, you can try that. Okay, it will improve inner ability, inner energy. Stretching exercise is very good. Okay, so we have to design some exercises and give to the chart. The chart we have to be give to the patient. So I advise you give do only for 10 minutes. The stretching exercise cannot take more time, first thing, and second thing is that it cannot take place also. In on the bed also you can do, on the here also you can do, like I am stretching myself. One, two, three, and you can stretch like that. So I stretch my chest part. So what will happen here? Muscles stretched a lot. and the blood flow to the region will happen very easily. And I will stretch my hands likewise. So you doesn't need more time. Whenever you want, you can do. First thing. Second thing is, you doesn't need any place, specific place you have to do. With that normal dresses, normal uh, things you can do with on sitting position also. Likewise, you can stretch your legs also like that. I am uh, sitting here like this. One, two. So it will deeply work. Okay. So I think you are also you can also follow that. So with that, the maintenance of blood pressure will happen. So not only heart, this thing's also important to maintain the blood pressure. So respiratory pump, muscle pump, okay, and contraction of veins. This is also important. Next, we have heart rate and force. In general, if heart rate and force increases, blood pressure increases. This is what happens during exercise. However, if the heart is beating extremely rapid, the ventricles may not fill completely between beats, and cardiac output and pressure will decreases. So what will happen here? If the heart beats very rapidly, likewise, without filling, the heart is pumping. Without filling, the heart is pumping. So it means it will decrease the heart rate also. Heart not. It will decrease the blood pressure. Okay. So we need normal heart rate, and force also. Okay. Next we have peripheral resistance. This term refers to the resistance of vessel offered to the blood flow of blood. The arteries and veins are usually slightly constricted, which maintains normal diastolic blood pressure. It may be helpful to think the vessel as the container of the blood. If a person's body has 5 liters of blood, the container must be smaller in order for the blood to exert a pressure against its walls. This is what normal vasoconstrict does. It makes the container, the vessel, smaller than the blood of volume. So the blood will exert pressure when the left ventricle is relaxed. If the more vasoconstriction occurs, blood pressure will increase. This is what happens in a stress situation. So here one resistance also important. Okay, means we have the blood vessels which constrict because of smooth muscles. So the constrict is in normal range. Okay, then the blood pressure maintains. Okay, pressure here the to the wall of the artery blood reach, then the smooth muscle contracts, then blood go forward, then contracts, then go forward, then contract. So what will happen? It will maintain the blood pressure, but it will become more constrict. The blood pressure increases. When this happens during stretch situations, it becomes sympathetic impulse. When you are in stretch conditions, our sympathetic pathway that we have to do one thing. Why this is not happening? So blood flow to the brain increases. Okay, because of stretchful condition. You are thinking now. Okay, if vasodilation occurs, blood pressure will decrease. After eating a large meal, for example, there is extensive vasodilation in the digestive tract to supply more oxygenated blood for digestive activities. To keep blood pressure within the normal range, vasoconstriction must and does our elsewhere in the body. This is why strenuous exercise should be avoided right after eating. There is not enough blood to complete supply oxygen to the exercise muscle and an active digestive tract at the same time. So basically, here one example is giving in stressful condition, vasoconstriction will happen. When we eat food, what will happen? The blood will reach to all the body parts. Blood will reach more amount to digestive tract for digestion of the blood. So in some other parts, the blood flow is low. Why? We doesn't need much blood there. Now our whole concentration is on the digestive tract. What happens? Then you will get some sleepiness and you have to relax for some time. So here two things are avoided. One is exercise is avoided. You cannot do exercise after eating meals because blood flow to the other body parts is decreased. So then only at that same time, if you are doing exercise after eating, body cannot give large amount to both sides. Then you will get weakness. Okay. So what we have to do, we have to take much amount of rest. Okay, so we'll continue the lecture